what you're looking at is a sheet of magnet 4" by 4" square, and the previous test has been done with this with the Starship coil. I don't know if you can see that circle. When you actually remove the film, the image drops by about 2/3. So we're going to actually redo it, but if you can see, we got the dark center and the white ring around it. And how you erase this to use it over again is to just use either a Starship with an AC coil on, or just this. I'm just going to use an N52 stack of magnets and just wipe it all over there, and it's completely demagnetized. So we're ready for our first magnetic test. The first magnetic field we're going to map is going to be a classic Rodin. This one is 24 turns. We're going to be using just one field, and I'm going to place the MagnaView film on top. Okay, and I'm going to turn the power on. We're going to be running about 15 volts at about 2 amps. And if you'll notice, you really don't see anything. The Rodin does not have a very strong magnetic field either at the top or bottom. Where is it then? It is concentrated in the center. A very thin line is where the magnetic field is. So how do we map that? We're going to take the I'm going to get on the other side here so I can turn the switch on. What we're going to do is take this, and we're going to put this film inside the, try to do this with one hand on, one hand off. Okay, like so. We're going to try to map it just like so. Okay, and I'm going to turn the power on and off. Okay, it's going to be a little bit difficult for you to see here, but there's a thin line going right here. You see a white line on the left. I wish this type of paper was more brilliant in showing this, but the Rodin coil has all its magnetic field concentrated right in the center because it's a radial wound coil. Okay, now we're going to see the field of this stacked N52 neodymium magnet. And obviously you'll see when you put the thing over it, you see that black spot? Okay, and if you raise it up, you're going to see the dots spread out, and that's the magnetic field shown in that magnet. This would be what the magnetic field would look like of each one of those magnets. And of course it's curved around and everything. Okay, this time we're going to do the same test as we did with the Rodin. Remember, we didn't see any magnetic field indicated by the MagnaView paper. Now remember, there is a magnetic field, but it was not strong enough to activate the paper. Now we're going to do the same thing with a Starship. This is the very first one I made. It's 21 turns, 22 gauge wire, 12 pedals. I'm going to lay it on top, and I'm going to turn the power supply on. Look at that. Look at that. Okay, and there we can go ahead and raise it up, and you're going to see that it doesn't spread out like the magnet. Look at that. It doesn't spread out whatsoever. So that vortex is formed straight up and down. The same exists for the opposite side of the coil. Now turn the power off, and you saw the image fail or fade away a little bit. Okay. Now, what I'm going to do next, I'm going to go ahead and demagnetize that sheet there, or not demagnetize. Well, yeah, it is demagnetized. Okay. And I'm going to coil this inside the Starship. Going to do it the same way as we did the Rodin. Okay. And I'm going to turn it on. And I don't know if you can see if I get centered there. I can see it, the field shown on the thing, on the paper there, but I'm going to turn it off. Okay, and there's a much more pronounced. Can you see the white, which would be right dead in the center, and you see the huge black on both sides? Let me move this up to center a little bit. Okay. Now, the next test is a smaller Starship, and this proves Marco Rodin's statement that the size of the coil doesn't matter it's how many turns you have. The only thing is, the size of the coil would be made if you had, to a certain size, if you had an armature that was either very tiny or very large, you'd want to have as big a magnetic field. So the diameter of the Starship coil determines actually the diameter of the vortex. I have my 4-inch Starship coil on the left, the copper enamel. You can see, well, it's a reddish coating. And next it is the smaller, I believe this was 3 1/2 or 3 3/4. You'll see the vortex hole is smaller, but you can definitely see it's a smaller coil. As we're going to see here in just a second, it's going to have the same magnetic strength in the vortex. And I'm going to turn it on, and again you right away see that huge pattern. And I turned it off and it fades just a little bit. Turn it on. Okay, and we will demagnetize this like we've done before. I'm surprised you can use a permanent magnet to do this that well. Okay, I'm going to insert this like I did before inside. I want to try to get this so you can see it inside the thing here. I'm going to turn it on. I can see it darken right there, but it might be hard to see in the video. Turn it off. And there is, you can see the white line with that would be right in the center of the Starship coil, and the black on both sides is the magnetic field vertically or of the vortex. I'll try to do a false color enhancement of these shots so you can possibly get a little bit better appreciation of what's going on. What I've also found is that current isn't as important as voltage, and so though current does have a thing to do with it, it's not as great. Now let me see if I can do this magic shot. I'm going to hold down the thing here. Let's see if we can do it again. Flip it again. Okay, well actually it levitated. Well, it's levitating. Let me just show you. I can drop the voltage down. You can see it. You can see it turn. I can drop the current down, and boy, it hardly makes any difference until it's almost no current. So right there is about the same, and I'm going to try to get a reading on that. It's about 1 amp. Let me get the power turned up. Yay! We got it done. It did. Okay, neat trick. Okay, if you remember, the Rodin coil doesn't even move the magnet. So here is I think a lot more scientific proof that the vertical stack winding, based on the Rodin math, remember this is a Rodin design, it's an alternative, has superior magnetic vertical vortex. However, the Rodin may have very, very important uses with that very fine magnetic line in the center. So I hope you enjoyed this.